Yahoo! Let's welcome to question 7. Alright, it says the rate of flow of water into a hot water system during a 12-hour period on a certain day is thought to be delta V over delta T, the rate of change of volume with respect to the change of time is equal to 10 plus cosine pi T over 2, where V is in liters and T is the number of hours after 8 o'clock in the morning. So this is very essential. T is the number of hours after 8, and V is in liters. It tells us units, and this is the rate of flow. It's given by this function during a 12-hour period, on a day. 12-hour period. So repeat itself every 12 hours. We can think about that. Alright, so the first question says, sketch the graph of the V dt against T. I'm going to be a Superman here, and I will just go Control V. There we go. After looking at the question, I already sketched it before I start this. So we got a graph from decimals. Let's give us that. No, just ignore this, just ignore this bit. Okay, so that's our graph. Alright, so that's done. Our graph is there. Let's make it bigger. Yep. Okay. So that's the first question done. Sketch the graph of the rate function against T. Alright. So, oops, stop popping out. And then find the length of time for which the rate is above 10.5 liters per hour. So find the length of time for which the rate is above 10.5 liters. So I guess we have to go to decimals again and draw another line over there, y equal to 10.5, and see where the two lines intersect. All right, give me a second. I didn't predict that, so I have to go do it now. Okie dokie. We'll come back. Look at I graphed the two function, right? The original function, and I also put a line of 10.5 equal to y in there to see all their cross or they intersect. So it's the question asks, find the length of time for which the rate is above 10.5 liters. So we got all this time here, right? So we got this one, this one, this one, this one, this one, and this one. Just giving up because I know they're periodic tape. The cosine is a period function, so they're going to repeat. So all I have to do is just to study one of the length, and that will be enough because they will be all the same. So we've got 4.667 here, which give me a feeling that is 4 2/3, yeah. And we got 0.662 to this one. So very easy. It would just be 4.667 minus 0.667. That will give us 4. And since our x-axis is time given in hours after 8 AM, so this is hours. 4 hours. So let's answer it. Find the length of time for which the rate is above 10.5 liters per hour. So the length of time for the rate to be above 10.5 liters per minute is 4 hours. Yeah, it's 4 hours for the length of time for it. Yep, 4 hours. All right, question C. Oh, getting nearly to the end. All right, find the volume of water that has flowed into the system between 8 AMs and 2 PMs and 3 PMs. Oh, okay, here it comes. All right, so we have to find the volume of water. All right, so volume of water. So we need the volume. So this one doesn't give us the volume. This one gives us the rate. So we have to integrate, right? We have to integrate. We have to move the t to that side and integrate that to give us v. So let's just do that first. All right. So let's copy down the function. dv dt is equal to 10 plus cos 10 plus cosine pi t over 2. I believe it was over 2. Yep, over 2. All right. And let's integrate both sides. Righty. Now, the interesting thing about this question is, he's asking us for the volume of water that has flowed into the system between. So we're looking for the total amount of water that has been flowed between the given time, 8 a.m. and 2 p.m. Now, we have to think. This function of the volume starts at, the t is the number of hours after 8 a.m. So at 8 a.m., the t would be equal to 0, right? There's no hour after 8 a.m. And at 2 p.m., let's count. Then there will be 6 hours after 8 a.m. So those two is the time. So once we're looking for the total amount of water flowing into the system between those two times. We have to use definite integral. So we have to put 6 on top and 0 for the first one. And then, let's just work out the other two as well. So 3 p.m. would be 1 more hour than 2 p.m. That would be t equal to 7. And 8 p.m. would be 12 hours after 8 a.m. So t equal to 12. All right. So let's just do the first one. Let's integrate it first. Let's see. Integrate that. We don't have to do that again. That would just give us v is equal to, let's break this into 2 parts. So we got that. Now let's worry about this. Let's worry about the sign at the end. dt plus cos pi t over 2 dt. Right? Let's do the easy one first. Now that is just easy. That will just become 10t plus this. Now, when you integrate cos, you get sine. All right, and whatever inside the brackets, we don't change it. And then we have to divide it by the derivative of the brackets. Inside the brackets, yeah, the derivative of that. All right. Now, there's no plus c, all right, because this is a definite integral, and we are doing it from 6 to 0. Okay, dokie. Now let's just make the inside looks better. So just equal to v equal to 10t plus 2 sine pi t over 2 all over pi. Remember what I said last time? So a over b over c is equal to a over b times c is equal to ac over b. So we got our a here, b here, c here, so we get our c, a over b. Yeah? So after that, we have to sub the values in. Alright, so volumes is equal to, first we sub the top value in. So it would be 6 plus 2 sine pi 6 over 2 all over pi. And then minus, so we're going to do the difference between them. So it would be 10, 0 plus 2 sine 0 over 2 all over pi. Okie dokie. So we get, so 10 times 6 is 60 plus 2 sine. Now we can just simplify that into 3 pi over pi minus 10 times 0 is 0 plus 2 sine. So we've got a 0 in there, so everything becomes 0 over pi. Okay, so that will give us, now sine 3 pi here, remember your unit circle or your graph. You can keep draw the graph. All right, you can draw that little. Let me use a different color. You can draw that little graph. Now we know here is 2 pi. All right, but we can just draw another half. That will give us 3 pi. All right, because each half is a pi. So 3 pi is, for sine 3 pi is still 0. So that would just be 0 over pi minus 0 plus. Now sine 0 is just here, so that would become 0 as well, over pi. So V is equal to 60 liters. Because the rest is just zeros. 0, 0, zeros. So there's 60 liters. So let's answer the question. Therefore, between 8 a.m. and between 2 a.m. and 2 p.m., 60 liters of water has flow into the system. Right. Okay, so let's just do the other one, right? So we already got our integral here, right? So I'm not gonna integrate it again. I'm gonna just sub in different values, right? So our integral here is 10t plus, I think, 2 sine pi t over 2 all over pi. That's our integral. And then we just sub in a different t. Alright, so it's 12, 7, so 12 goes on the top. Alright, 7 goes on the bottom. Okie dokie, let's just sub things in. Okay, so it's 10 times 12 plus is 2 sine pi 12 over 2 over pi minus 10 times 7 plus is 2 sine pi 7 over 2 over pi. Okie dokie, so V equal to 10 times 12 is just 120 plus is 2. Now this becomes 6 pi, and we know from the previous diagram, all right, all the pi's will give a 0 value of sine. So that is just 0 over pi minus 10 times 7 is 70 plus is 2 sine. Now that will give 7 divided by 2. Very good, which is 3.5, which would be oh, this is embarrassing. 3.5 pi in there. Alright, so let me just look. Alright, I know 2 pi is here. 3 pi is here. So here must be 3 pi over 2. No. This must be 3.5 pi. Because it's 3 pi's there, so this is 3.5 pi, and that's 4 pi there. So 3.5 pi will have a -1 value of sine. Alright, so they will give us 120 minus 70 plus 2 times -1 over pi. Radio, that will give us V equal to 120 minus 70 minus 2 over pi. Alright, let me just do all the calculation at once. And at the end, it gives us 50.63. Let's just run out to the second decimals. So 64 liters. So that's the answer. That's the total amount of water. So therefore, let's see how I answered the previous one. Between 8 AM and 3 PM. So this time is between 3 PM and 8 PM. Approximately. It's because round things up. 50.64 liters of water flow into the system. Great, so that's that answer. And wow, I suppose that's it. That's question 7. Whew. All right. My hand's getting sore again. All right, let's just take a commercial break and we'll come back later for question 8.